Alright, the name of this lesson is Simplifying Complex Fractions. So, you might be asking, what is a complex fraction? Well, of course, the word complex means kind of advanced or more complicated, I guess you could say. But complicated has a negative connotation. So complex, let's say more challenging, right? More intricate. Here's an example of a complex fraction. Now we're going to be doing some much easier than this to start out with, but we can see that this fraction bar right here represents the big fraction, and we have 4 individual fractions inside of that fraction, 2 on top and 2 on bottom. Okay, the one on top is being subtracted, the one on bottom is being added. So a complex fraction is when you have fractions within fractions. And there's your definition, okay? And here's just some more examples down here. You can see what a complex fraction looks like. Alright, so let's go ahead and get to example 1. We have 5 over x plus 4, which is one fraction, divided by, this is our big fraction bar, 1 over x plus 4 plus 2 over x. I've already drawn some arrows here from a previous lesson, but this is indicating that we need to combine these two fractions on the bottom before we can do anything. So step 1 is going to be to combine the expressions, either adding or subtracting them. So to combine those two on the bottom, let's go back and take a look. We need to find the LCM of these two things. So really, the LCM is just x times x plus 4. In other words, each fraction needs to borrow the other's denominator. So I'm going to multiply the left by x over x and the right by x plus 4 over x plus 4. Just like that. Okay? So that will become 1 times x plus 2 times x plus 4 on top, divided by a common fraction of x plus 4 times x. This right here will simplify to x plus 2x plus 8. And of course, x plus 2x is, you guessed it, 3x. And I don't know why I didn't do that before, but anyway, that is equal to 3x. But anyways, I guess there's a reason I left it that way. Yeah, so the reason I left that way, now I thought about it, was, sometimes it's better to wait till simplify till later, especially with these, because a lot of times you can cross stuff out without having to simplify all the way. This one, though, I think if I went back, I would have changed it to 3x. But anyways, you'll see why later on you want to leave things the way they are sometimes so that you can cancel common factors. Especially with this x plus 4 and x, you can see that those are going to cancel, cross-cancel. Alright, so the next step is to basically, it says divide the denominator. I know a lot of you, though, have heard a different wording for this. And the wording is keep, change, flip. So when you divide a fraction by a fraction, you keep the top. Okay, that's way too thick. Okay, keep the top. So this is the top fraction. Okay, keep the top. You change the division sign to multiplication. And the third thing you do is flip the bottom. So we are flipping the bottom, and it's going to become x plus 4 times x, so flipping it, the bottom to become a top, over x plus 2, x plus 8. Alright? So, again, after you combine this bottom into one fraction, or the top if it had two different fractions, then you keep, change, flip to get your new fraction. And rather, it's a fraction times a fraction. Okay? Our ultimate goal is one fraction, actually. Alright, and then there's one final step, which is just to simplify. So you can see right off the bat we can cross-cancel these x plus 4s because they're the same factor. And we're left with 5 times x on top, and then we still have the x plus 2, x plus 8 on bottom. Like I said, if I had to do this again, I probably would have just combined the x and the 2x. And I finally did with this step. So x plus 2x is 3x. And that's our final answer, 5x over 3x plus 8. You can see it's a lot simpler than what we started with. And again, the 3 steps are simple. We're going to combine the expressions into one single expression on top, one on the bottom, one fraction on top, one on the bottom. That way for step 2, you can keep, change, flip. Alright, keep the top, change this to multiplication, flip the bottom. And the final step is to simplify, which normally involves cross-canceling or canceling up and down. Okay, of course it also involves PEMDAS and combining like terms like we did here with 3x. So if you have any other questions about this example, let me know. This is example 2, a preview. We'll do that in the next video.